So today, following in the theme of doing shorter videos from home using this small blackboard, because the coronavirus has of course forced us all into our homes, I want to pick up a theme that we started a couple of days ago, which was variables, and talk about something closely related, which is equations. And I want to illustrate the idea of equations and the power of equations with kind of like a little riddle, which will show us how equations are mathematical ways of encoding constraints. So let's say we imagine a person who has three types of pet. They've got dogs, they've got cats, and they've got birds. And I'm going to tell you some facts about the number of pets that they have. So one fact is that they have two more birds than cats. Another fact is that they have twice as many cats as dogs. And the last one is that the mammals outnumber birds by 1. And I'm going to show you how we can transform these three constraints into three equations and use those equations to solve for the actual number of animals that this hypothetical person has. And to do that, I'm going to use three variables representing the three things that I want to solve for: D for the number of dogs, C for the number of cats, and B for the number of birds. And I'll translate these three constraints. So the first one says there are two more birds than there are cats. So that means if I take the number of cats and add 2 to it, I get the number of birds. So this is an equation that represents this constraint. Now there are twice as many cats as there are dogs. That means if I take the number of dogs and multiply it by 2, I get the number of cats. And finally, the mammals outnumber the birds by 1. Well, the mammals are the dogs and the cats, so that means if I take the dogs and the cats and put them together, that outnumbers the birds by 1. So that's the same as the number of birds plus 1. So these three equations here represent respectively these three constraints, right, using the three variables that I'm trying to solve for. Now what can I do with this? Well, one thing I can do is I can take the first two equations and put them together and say, look, I know that C is the same as 2D. Right? The number of cats is the same as twice the number of dogs. So I can substitute 2D for C in the first equation and get 2D plus 2 equals B. This is putting together equations 1 and 2. I can also put together equations 2 and 3 in the same way. I know that C is 2D, so this C is also 2D. And I get 2D plus D, right? 2D plus D equals B plus 1. Now I can put these two equations together. Right? I know that B is equal to 2D plus 2. And so I can substitute 2D plus 2 for this B down here. So I can get 2D plus D equals 2D plus 2, that was this B right here, plus 1. Now if I simplify a bit, I get on the left-hand side 3D equals 2D plus 3, and subtract 2D from both sides, and I get D equals 3. So the number of dogs must be 3. It just follows from these three constraints up here, which are the mathematical translations of these three constraints. And if the number of dogs is 3, then the number of cats must be 6. And if the number of cats is 6, then the number of birds must be 8. And we can check that these three numbers, 3, 6, and 8, satisfy each of these three constraints. And moreover, because we derive those three numbers just by using these three constraints, it means these must be the only three numbers that actually satisfy these constraints. So that's a little peek into how to use equations with variables to figure out unknown quantities.